Okay, we're going to run through the procedure for the gravimetric analysis lab. Some of the things that you would have in your lab as you're running through this would be a ring stand with a funnel and a filter paper. You would have some type of a stock solution laid on the bench, which is the calcium chloride solution. It's clear. It's like any old liquid. You would have some type of a container with the mystery metal carbonate hanging out on the back bench. You would have a balance, and you would have a Grav cylinder to measure off your volume of the calcium chloride. And then you would have a drying oven somewhere in the room as well. As far as what you would do, one of the very first things you would do is you would take the mass of the filter paper. Because later on, this thing's going to get wet. You're going to have some calcium carbonate sitting in here in the oven. You need to get the mass of the calcium carbonate, but it's in the filter paper. So you have to make sure you subtract off the mass of the filter paper. So one of the very first things I would do is I'd write my initials on here so I know it's mine. And I would come over to the balance. I would make sure it reads 0. I would put this on here and get the mass recorded in my lab. With that, I've got this little cupcake tin thing. And this is just used to kind of carry around certain masses of whatever stuff you're measuring. This is on the balance. I would hit the 0 button. Make sure it's not reading any of the filter paper. I would use a little scoopula, and I would go in and get some specified amount. It doesn't have to be exact. If you notice your lab, it says something like around 2 grams. I would go in, grab whatever certain amount. I'm going to place it in here until I get to whatever amount I am satisfied with. But very important, make sure you write down specifically as many sig figs as this balance allows, and it happens to give me 3 decimal places, the thousandths place. I would record that down on my sheet as accurate as I can because it bounces around a little bit. And then I would take this tin and take all of the mass and place it into a beaker. I've already kind of run this, so just kind of showing you what we have going on. So I place it in a beaker, which is clear, distilled water. How much volume? As little as possible, because the more volume you put in here of distilled water, the more you have to filter through the filter paper. And it's going to take a while. So I just put a little bit in here, and then I kind of stir it around and let it dissolve. It will dissolve. The metal carbonate, group 1's metal carbonates, will dissolve completely in water. From here, I would measure off the specified amount. Your lab says 125 mils. I'll give you very specific information later. It doesn't really matter because this is in excess. I just need enough. How much is enough? I don't know. I'm telling you about 125 mils. So I would take and I would fill this up, and I'm not even terribly concerned. So whatever number I tell you is specifically put in there, 125 mils, this is 100. I modified the lab a little bit so I could use 100, using less. From here, I would pour it into the beaker, and from there, it turns cloudy because I have produced, with the chemical reaction in your lab, we have produced calcium carbonate. And it's kind of cloudy. Now this I've actually kind of let set for about 10 minutes or so. But because I'm going to filter it, I want to kind of stir it around so I get it in suspension. And then I would take it and pour it into the filter paper. And I'm just kind of putting it over the sink because I'm not terribly concerned about what comes out the other end. I'm more concerned about what I'm capturing in the filter paper. So when I place it in here, I want to keep it about as much as I can without going over the edge. And I keep doing that until all of this is gone. If I got a little debris on the side, what I would do, I don't have one with me right now, I don't want to go grab one, is I would use a squirt bottle and I would squirt until it goes down into the filter paper. So I'm getting all of that precipitate out of the beaker and into here. Which brings me to the idea of potential errors in your lab. Sometimes in answering questions, these are really good AP questions. You're answering a question and it says, okay, your answers aren't what you might have expected them to be, or you should have gotten this, you got this for an answer. So if your answer should have been 50, your answer is 45. Why? And the go-to answer is incorrect measurements. Those aren't good answers. You have to specify why is your answer too low. So for example, I'll give you 2 different things going on here. And this is probably in your lab. One is I'm pouring this into my filter paper, and some of the calcium carbonate that's in here goes over the edge and goes down into the sink. I don't capture the calcium carbonate that should have gone into the filter paper. It went somewhere else. How does that affect my results of metal carbonate? Doing the stoichiometry stuff later on. That's one potential error. My question to you is, how does that affect your answers? Does it make it too high or too low? Well, throw in some numbers. You lost some. So which went down or up? Did the calcium carbonate that I captured go up or down? How does that affect your results? Another thing you could have as a potential error is I'm doing this while I'm weighing out of the solid metal carbonate initially. But I kind of screw up. Some falls off on the table. I spill some on the table. So what I recorded on the balance is more than what I transferred to the beaker. How does that affect my results? Well, play with numbers. You have your results. Let's just pretend that you lost some. Go ahead and recalculate your data. Did it make it too high or too low? These are the kind of questions that would be put to you, and you would have to go back and answer. Oh, that would make it too high, that would make it too low. Those are very good AP questions. Okay. After this process has gone through, you would have collected in here all the calcium carbonate from the beaker in the filter paper. It's wet, it's nasty. I would take it and I would place it in the drying oven for some amount of time. Usually it's a class period of the day. Next morning, you come in, you pull out your filter paper with calcium carbonate. You place it on the balance. It's got a total mass, but you know the mass of the filter paper. With the mass of the filter paper, I subtract that off, and now I have a mass of metal carbonate. Excuse me. I have a mass of calcium carbonate. With the mass of the calcium carbonate, I can now do my stoichiometry, as I showed you on the board earlier, and translate that over to the total mass of the metal, or excuse me, the number of moles of the metal carbonate that I initially have. Moles of metal carbonate, mass of metal carbonate, molar mass. You got it.